anything that you might choose to share with me. On the human web, we typically treat our resources as web pages. It might be the latest IPL results, for example. That could be a resource. In the computer-to-computer web, we may choose to expose information about human resources records. So you may be able to integrate to the ThoughtWorks HR system and see all of the reprimands that I've got for suggesting that the web is about transferring dirty pictures. It's about that long. You do need to cache it, because I say it a lot. But it can be anything you like, and we're not restricted, really, to web pages, because the web is ambivalent about the kind of traffic that it carries. So we interact right on the web, have a pointer to my objects. I may freely exchange with you representations of my objects, snapshots of their value, of their state at a point in time, but you'll never get a pointer to me. And if my objects go away, fine. We're loosely coupled, you shouldn't have been looking in my internals anyway. And so each of these resources, gazillions of them as there are worldwide, all have one remarkable thing in common. They all implement the same interface. The same uniform interface that HTTP gives us, HTTP verbs give us. And so a resource architecture looks a bit like this. We may have some physical resources. Maybe those physical resources are data. And maybe they're in one of those charming legacy relational databases. So any database people in the room? There must be some of you. Okay, so I'm going to use the word legacy database all the time when I refer to relational databases. So hopefully that will raise a few heckles and someone will yell back at me. No, that's okay. So maybe we've got some physical resources in a non-legacy graph database or a non-legacy document-centric database. Maybe there we choose to expose some of those resources in a logical manner so that people across the web can interact with them, can consume them, can change their state. So we've got some logical resources which are going to be hosted by our web server. This remote. Great for watching movies, really poor for presentations. And what's good about that is the web server implements the uniform interface. It wraps the uniform interface around all of those resources that we might want to share with other systems out there on the web. On the wire, we have those resource representations, an encoding of the resource state at a particular time. And we may elect to use formats which are convenient for us to encode those resources. We may choose XML because that's quite machine processable. We may choose JSON, also quite machine processable. We may not choose MP3 because that's really hard to process for a machine. Imagine a machine trying to listen to an MP3 and then figure out what processing to dispatch from it. It's probably a bad choice, but you could do it and the web wouldn't really mind. This makes your systems a lot harder to build and test. And then at the consumer end, if you like, the client side, we have a consuming program, a consuming application, which itself may be a service, built from standard nuts and bolts HTTP libraries. Nothing extravagant in this. It's the same kind of tools that we use every day to build those wonderful 3-tier Java web applications and so on and so forth. So on resource representations, we know that, or we don't know, but I'm going to assume for the moment that making your system, your service, web-friendly increases its surface area. Because in a web-friendly system, we tend to expose more resources rather than fewer endpoints. If any of you folks are familiar with the WS star style of resources, we typically have one endpoint, and all messages go in and out of that endpoint. That's fine, it's the moral equivalent of a letterbox. Letters go in, and then, okay, strangely, letters might come back out again. On the web, we don't really go for that style of encapsulation. I expose to you my logical estate of resources, and you guys pick, through URIs, which ones you'd like to interact with. Every resource, of course, has one or more representations. Now, I already mentioned XML and JSON as sensible options. As we'll see later in the tutorial, I'll favour XML-ish dialects for my resource representations. And moving these representations over the network is the way that we interact with the service to get work done. So it's kind of almost like pass by value. URIs. URIs are the fundamental building block for the web. URIs in the HTTP context, I'm going to be careful here because I've already had an argument with the previous speaker about this. And he was wrong. Not often he's wrong, but anyway, in this context he was. Hello back there. In the context of an HTTP URI, I'm going to take the liberty of calling them an address. Because on the web, an HTTP URI is kind of synonymous with the address of a resource. Now, URIs aren't addresses in the general case, but in the web context, I think they are. So I'm going to say that every resource has at least one URI, or it's not on the web, and that URI can be used in the HTTP or web context as its address. So if you know the URI to my blog, for example, you can dereference that URI and you will find my blog giving you a resource representation which happens to be XHTML. Any resource implements this interface, so whether you point your web software at my blog or Ola's blog or my coffee ordering system, they will all respond at the wire level in exactly the same way. And this is lovely because it means that when we access it programmatically, there are very few surprises. Of course, it doesn't, just because we have a resource doesn't mean we have to be limited to one URI. Resources may have many URIs, and again, we've seen this on the human web. You may go to bbc.co.uk/sport/cricket. I'm sure none of you have done that today, several times already. Or you may choose to go to www.bbc.co.uk/sport/cricket. Two different URIs, both pointing to the same resource. Now we can, on the web, have a system called canonical URIs, where we take one of those URIs as being, if you like, the default long-lived URI for that particular resource. And you can have other non-canonical URIs which may change over time. Good example of this is when we download software from the web. We always go to blah, 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 /latest, and over time the actual resource that /latest points to may change. But we may also have a canonical URI for a particular version which sticks with that resource forever. And it is this fixed URI which is the canonical one. The web actually also gives us a way of dealing with that. In the content location header, for example, you're allowed to tell someone the canonical URI of the resource. So if, for example, you accessed /latest in the content location header, should the web service you're using be a good guy, he will also tell you that, yeah, currently you're accessing /latest, but if you ever want to see this in the future, I suggest you use /1.4. So the web's already got mechanisms to help us do sensible kinds of versioning. It's also got, of course, things that we're used to from the human web, like see other, the 300 status codes. Okay, so that's the nuts and bolts of the web. But here are the characteristics. The human web is, when it breaks, I can often pick up and keep going from where I left off. If I'm looking for photographs of the Great India Developer Summit and I hit a link that's broken or a server that's down, chances are that that data may be replicated somewhere else, maybe even in the same server farm, so it's quite fault tolerant. Also, the web gives us metadata, so that 404 bad status code isn't a bad status code at all. It's telling us, couldn't find that, so why don't you look somewhere else? So it's giving me direction. It's already trying to help me to reach a successful conclusion. It's secure. Well, we know we can use HTTPS, and that's a very mature technology for ensuring privacy and tamper-proofing. And it's loosely coupled. And this is perhaps the loveliest thing about the web. When I deploy another system onto the web, do I break your system? Pretty unlikely. However, how many of you guys, and I'll admit to this freely, have built enterprise systems where you deployed this new module which shouldn't have any effect on the rest of the system, only to find that that thing over there broke? Yeah, a few honest people in the room and a few people who are like, I'm not risking my professional reputation answering that. So I'm going to guess 90% of you have been in that situation. The other 10% of you are managers or something, and you're just covering your tracks. Naughty. So the web has this thing. Deploy stuff, it doesn't break other stuff. And that's a really desirable characteristic. In fact, these are the same characteristics that we strive so hard to achieve in enterprise software development. So let's think about these a little bit more deeply. Scalability. Well, we know the web's at internet scale. It scales because it's loosely coupled. Growth of the web in one place isn't impacted by growth elsewhere. One of the key drivers behind this is the uniform interface. Nothing on the web ever gives you a surprise. So I don't know if you guys have been attending some of the kind of Ruby-flavored talks over the last few days. Certainly, I feel like a groupie to Ola because I've kind of been in most of his talks. And he talks a lot about the principle of least surprise in languages. So that once you're familiar with the idioms of a language, you can kind of guess very easily about how to do something you've never done before. And 9 times out of 10, you'll be right. The web embraces this same philosophy. The web because it's based on a single HTTP uniform interface, has no surprises in it. Everything you interact with on the web responds in the same way. It responds to the same verbs. It produces the same status codes. It has all the same metadata. So when it comes to scaling out services, deploying millions and millions of services globally, because of the principle of least surprise, we end up being very successful. This also means, because of the uniform interface, we can do smart things, like we can bake caching and proxies into our network, which help us deal with some of the huge, dramatically huge in some cases, load that we place on the infrastructure. And also the web is stateless. So unlike object-based protocols, the web insists on every interaction you provide all of the information needed to successfully complete the request. Which might sound like overhead because you have to send potentially a few more bytes over the network each time. But the benefits of that is that the web enables trivial, stateless, horizontal replication for scale out. And because the web's stateless, not only do we get benefits in terms of scalability, but we also get benefits in terms of fault tolerance. So if you think about, have any of you guys ever written crash recovery protocols? And again, it's a cause of hair loss, I can attest. Statelessness means that any one of my servers in my server farm can pick up and keep going in the presence of a failure of another node in my farm. So if a machine crashes, any other machine is equivalent. It can still continue to handle the traffic. Statefulness hurts you because a particular machine carries state for a particular session or interaction, and should that machine crash, you get unpredictable results. It makes fault tolerance very difficult, particularly makes crash recovery very difficult to code for. So being stateless enables you to build simpler systems that don't worry about crash recovery because you just fail over horizontally to another node in your machine. So it makes replication of service for availability reasons very easy. The protocol itself, while we're on a kind of pessimistic crash recovery theme, also enables us to do smart recovery. Because the web places such an emphasis on being able to retrieve information safely and repeatably, we all know, of course, HTTP GET underlies this. When we crash, finding out where we were in a particular business process is quite easy. We just get the state of the resources we knew about, and we recompute where we got to in our business process, pick up and carry on. And that's safe to do because doing a GET doesn't change state, or at least it doesn't change state in a way that clients can be held responsible for. And there's an anecdote here. I don't know if it's true. I think it may be urban myth. But back in the day, when the human web was in its infancy and some leading edge pioneers were trying to use the web for all sorts of fun things, the US Library of Congress did the most amazing thing and decided to put its book catalog on the web, which is great, right? I mean, imagine how nice that was back in the early days, being able to browse the Library of Congress catalog. And even more helpfully, if you wanted a printout of a particular web page, there was a link that you could click on, and then a piece of paper with that web page would come out of the printer. And that was fantastic. Imagine the convenience of that as a user. Like, oh, this is a really useful article for my PhD thesis. Click, out comes the piece of paper, back to my office, do the work I need to do. And then, of course, imagine their surprise when the first web search engines crawled their pages. And what did the web search engines do? They clicked the print link while they were searching. They violated the shared understanding of GET, did the Library of Congress. And the side effect? Amazon forests worth of paper flooded through their printers, and it was bad. Why? Because the Library of Congress violated the fact that GET should not have side effects. GET shouldn't have side effects because we rely on it for so many other non-side effect things. Not only do we have that, though, but HTTP also gives you, I feel like a game show host, not only do we have GET, but we also have metadata, which helps us to deal with failure scenarios. We have HTTP status codes like 404 or 303, or like 409, where we say there's been a conflict. All this rich metadata helps us to make sense of potential failure scenarios. And some of the verbs are actually fortuitously well crafted to help deal with those too. So the semantics of put and delete, as we'll see, are really helpful when it comes to dealing with fault tolerance issues. So security. We've already got HTTPS. We're familiar with it. We're comfortable with it. It's remarkably well done. It's remarkably sophisticated. But the one downside with HTTPS is that it isn't so sympathetic to the web architecture. In particular, it bypasses caches. And caches are kind of cool, and we like them because they help us to federate load. So what's happening now is you're starting to see higher order protocols implement security slightly differently. So you're starting to see, for example, atom feeds where only entries are encrypted, and the rest of the feed, or at least, links to the entries, or the entries themselves are encrypted, but the feed itself may be cacheable, it may be in the plane. And of course, then you're using same old crypto techniques that we're always used to, but we're starting to learn how to apply them in a way which leverages or retains some of the benefits of the web in terms of caching, while still giving us that high level of security we need. And so the web's loosely coupled. We know that adding stuff into the web doesn't disturb it. All the web actors support the same uniform interface, and it means it's easy to plumb new stuff in. So what if you've built a web-based service and you find that it's remarkably popular? Maybe you've built some kind of a financial exchange and you're cheaper than the competition. Your traffic ramps up beyond all belief. Scary. But one of the things you can do very easily on the web is elect to put a reverse proxy server, properly configured of course, in front of your origin server to potentially take some of the repetitive load away from your origin and away from therefore your back-end databases and so on. And because of the web's uniform interface, that can be done transparently. That's pretty important. I've never been able to do that with any of my other distributed systems technologies. I've never been able to do that with Corba or WS Star-based services, for example. So all of this adds up to being a really fascinating platform for distributed systems geeks. And so we want to learn to build stuff with it. So let's start with a tech interlude. Let's start by talking about URI templates. So URI templates are a metadata format. A metadata format which allows us to describe how URIs for a particular service might look. And immediately we come across a philosophical divide in the web community. Half the web community, particularly those who favor the hypermedia style of services, which I hope to persuade you of at some point, suggest that URIs shouldn't be computable, suggest that they should be opaque. The other half of the community says that cool URIs are human-friendly. You can inference things from them. You can be given one URI, you should be able to compute another. For example, if you saw that URI to one of my old blog pages, jimweber.name/2007-06, you can probably guess that's the archive for June 2007. If I asked you to find the archive for July 2008, given that URI, you could probably figure it out, right? And that's maybe a good thing. What effectively I'm doing is inviting you to compute other URIs that might resolve in my blog engine to give you useful data. Of course, if I ever decide to change the format of that URI, anything you've computed is invalid. So what we did do, perhaps inadvertently then, was couple ourselves together through the inferencing of the URI, through effectively the URI template. If I give you a tiny URL, you can't really inference anything from that. Doesn't really give you any, or indeed if you've seen any of those long URLs that are full of like a munge string, you can't really inference anything from that. So the downside is you can't guess other URIs that might be useful for you. The upside is you can't inadvertently introduce coupling. And Tim Berners-Lee actually prefers this style of URIs, which is it's kind of hard to argue against given that like he invented the web and stuff. But URI templates are in use today. Successfully, in fact. And perhaps the most famous example of which is Amazon and Amazon's S3, Amazon Scalable Storage Service, which gives us a kind of massive, scalable hash map-like abstraction. Wow, I feel like a supermodel, thank you. Of course, the actual supermodels are in no real threat of losing their jobs to this face, but anyway. So Amazon S3 shares with us a URI template, and it splits the addressable space, if you like, into buckets and objects. And it gives us this URI template here. So if you want to access your objects that you've stored in Amazon S3, you give it a bucket name and an object, and then you can interact with that object through HTTP. And of course, you're now invited to infer new bucket names, new object names, and so on. Of course, you're now quite tightly coupled to Amazon's URI scheme, and if Amazon ever decide to change that, it's really going to annoy you because all of your programs will be written for this URI scheme specifically. But it works. That's a lovely thing. The wonderful thing about URI templates is that they're quite easy. You take a URI like this, and you do the substitution. So the bits in curly braces, you're invited to vary. So for example, if you look at the restbox.com service, which we'll talk about in depth later, it used to be starbucks.example.org, but I got a bit nervous that Starbucks might sue me. So Restbox is a British coffee shop. The coffee's terrible, the service is rubbish, but at least it probably won't get me sued. So anyway, should you be given that URI template for Restbox, you might well decide that you can substitute order ID for 1, 2, 3, 4. Cool, or maybe 4, 5, 6, 7. And maybe then that references particular coffee orders that Restbox have taken. If I give you a more complicated URI template, for example, restbox.com/orders/shop/year/month.xml, you may actually think that you can vary, orders shouldn't be in curlies, mistake. You may actually think that you can vary shop, year, month to get the records of particular orders for a particular shop, year, or month. And you'll be invited to do that because the URI template has said, hey, vary these things, you'll get interesting stuff back. So these are great things. They do make computing URIs and interacting with services quite easy. In fact, these things are, if any of you have ever seen a WSDL document in your lives, well, you have my empathies with you. But these things are way easier to understand than WSDL. You've seen, even if you've only seen URI templates for the first time right now, you already know how they work. You could already use them in your software today to start building stuff. But it does introduce coupling. So, I still think that regular URIs are a good idiom in web services. I still like to look at a URI that says restbox.com/orders/London/12th of August 2008. That's helpful for me. It makes, that readable idiom is really nice. It helps with understanding, and it also helps to document your service. URI templates simply formalize that. They're a standardized format for describing those and sharing them between us. Now, because everything in the web has a URI, we might want to use URI templates to start describing the URIs on the web. But they do introduce coupling, so we have to be careful when we use them. In fact, I tend to use URI templates only for what I'd call entry point URIs into a system. And any kind of internal stuff, I tend not to share my URI templates with outside consumers. I tend to use that as internal documentation. So I think there's a good mix. URI templates are great, so I'll invite you to Restbox, and maybe there's a special login that you can use because you're a privilege card holder, and you can vary your privilege card ID. After that, I tend not to use URI templates. So we know about URI templates. Let's see how we can abuse them, along with URIs, to do the same old RPC that we've been doing for years. So we know that the web community hates SOAP. It doesn't mean that they don't shower, it means they dislike the simple object access protocol. Whether they shower or not, it's a mystery, I don't know. Unfortunately, a lot of web people do the same. And particularly, particularly those people that have an aversion to SOAP and web services of that style seem to have been quite vitriolic about how SOAP abuses the web. And indeed, some of the frameworks that we've built really aren't that sophisticated. But the web is permissive. We don't have to necessarily be good guys all the time. Sometimes tunneling through the web is just what we need to do to get a small piece of integration or some rapid integration done. Now, this isn't very mature, according to Richardson. So if we use URI tunneling, we only use one bit of the web, the addressing bit, the URI bit. And although technically it's level 1 because it uses URIs, URI tunneling really has more of a level 0 mindset. Because it doesn't really use URIs as addresses, it really uses them as a way of bundling parameters together for a procedure call, as we'll see. It doesn't really understand HTTP either. It doesn't really understand those useful status codes or any of that metadata. And it absolutely doesn't understand hypermedia. So these are quite unsophisticated services. Level 1 is probably being very generous. I think URI tunneling services are really much more level 2. But the pattern's very simple. And sometimes you just have to be pragmatic, hold your nose a little bit, and do it. And the wonderful thing about URI tunneling is it's the confluence of two very simple mechanisms. URIs have structure. Yeah, we all know that. We also know very well the structure of HTTP URIs because they're part of our everyday lives. I see them painted on buses. That's how commonplace they are. Methods have signatures. They take stuff in and sometimes spit stuff out. And it turns out that it's quite straightforward to match the structure of a URI onto the signature of a method and use a URI to convey data to a remote method. So in this case, I apologize for the relatively small font. You guys at the back just pretend you can see it or get the binoculars out, either way. And what can happen is we can construct a URI which has a whole bunch of parameters here and use a GET request to move that URI from the client to a remote server. The remote server unpacks the URI, figures out what the parameters mean, and then uses the values attached to those parameters to dispatch to a local method call. So effectively, using nothing more than a single HTTP GET, we can now invoke remote methods. On the wire, it looks pretty simple. It's a GET request to a particular host, and if all goes well, we just get back a HTTP 200. Bingo, everything's okay. It's pretty simple stuff. You could probably have written the code faster than I can write the PowerPoints. And we can build it pretty easily. Bugger. Let's see if I can zoom this. Any better? Is that visible? Okay, cool. So it's really very easy. So, server side, just have a method here which takes, this is .NET, take in HTTP listener context, parse out the URI from the request, whoops, from the request query string, formulate a response by dispatching to my place order method. So if that's this guy, here is where my business logic is done, craft a response in some way, and then dump it back into the output stream. Trivial. On the client side, similarly trivial. We spend all of our time just mucking about with strings to create the URI. Then we just, whoa. Then we just bounce it over to the server. We set up our HTTP request, fill the URI up, bounce it over to the server, and that's it. On the response, we then just demodule it into an order confirmation and return it. It's really simple. It's just mucking about with strings. You could write that in seconds, which is a strength of URI tunneling. It's really easy to understand. It's really good for simple procedure calls. It's really, really easy to code. So you saw some .NET code there. You could do the same thing in Java with Apache Commons and servlets really easily. You could do it in Rails or any of the kind of cool kid Ruby frameworks, and it wouldn't take you very long to do it. And for some integration domains, it may be the right thing to do. And perhaps the best thing about this is it's hugely interoperable. Does anyone know a platform that doesn't understand URIs in the 21st century? I don't. Every platform under the sun understands URIs. Your wristwatch probably understands URIs nowadays. It's just they're just so broadly understood. But of course, there are downsides. There's always a downside. I'm a Brit, right? So as I said yesterday, swings and roundabouts. Things that make us happy, the England cricket team, often disappoint us, the England cricket team. And URI tunneling is like that. Makes me happy because it's simple, but then it disappoints me because it introduces problems. So it's very brittle. It's a very brittle RPC mechanism. If you change the signature of your method, which you're quite at liberty to do, it's your method after all, we break. It introduces tight coupling between the client and server. If the URI format changes, we break. There's no metadata to help. There's no warnings. There's no ways of communicating changes very easily. It's also not very robust. If something barfs, maybe your method throws an exception. Maybe my place order method barfs because it can't connect to one of those charming legacy databases. what happens then? What does the failure mean? Oh, I've got an exception. Does that come in an HTTP 200, or does it come in a 404 or a 500? It's really confusing. There's not really any hard and fast rules. And perhaps the worst thing about this is that it encourages us to do the thing that the Library of Congress allegedly did. It encourages us to abuse get. It encourages us to use the special verb get to do actions which have side effects. And that's criminal in the web world. Or at least in the purist web world. So yes, you can use URI tunneling. It may even work in your situation, but don't brag to your mates down the pub about it because they're going to pour scorn on you for it. Similar with the POX pattern. So POX is another element of permissive web integration. And POX, or plain old XML, takes advantage of the fact that web servers know how to understand and process payloads conveyed to them as part of HTTP POST. So we're used to that from the human web again, right? We're quite used to collecting name-value pairs from web forms and posting them to the server. And of course, we're not restricted on the web to name-value pairs. We can actually do other things like post XML values from a client to a server. The server can then parse the XML, understand the intent, and do some processing before itself responding with another XML document back to the server. And POX uses this. POX basically says, well, I've got this HTTP thing. It's kind of a good transport protocol. And I use the word transport deliberately. And it goes through firewalls. That's really very lovely. So why don't I hijack that and start sending XML payloads back and forth over it? In this case, Richardson is rather unfriendly about POX. It's a single endpoint, single well-known endpoint, just like SOAP services, just like XML RPC. And it doesn't really understand HTTP other than as a transport. It doesn't really understand that HTTP has these other sophisticated things that we might leverage. And there's absolutely no hypermedia involved whatsoever. So it really is a kind of primitive level service, if you like. Doesn't mean it's bad necessarily, it just doesn't embrace much of the web. Architecturally, it's pretty simple as well. You have some client-side business logic. We dispatch to a method call, which maybe masks the remote behavior of the operation. The dispatcher converts our local values and objects into some XML format, passes it down to some standardized HTTP client, which pushes it over the wire. On the other end, the recipient of the HTTP post does the inverse. It turns the XML into some local objects, dispatches them to some application logic, some business logic, and on the return of that business logic, gets turned back into XML, gets sent back as the HTTP post response, gets received by the HTTP client, turned back into local objects, and turned back and dispatched back to our business logic. So the architecture is really simple. It's the same kind of architecture, actually, that a lot of the web services toolkits are built on. So it looks very familiar to us as distributed systems practitioners. On the wire, it looks like this. And let me see if I can do that cool Mac Zoom thing again. It's just XML going over the wire. So that's a very blurry HTTP post that you can see there. Carrying, in this case, a RESTBux coffee order over the wire to the RESTBux service. And if I can come down a bit, assuming that all goes well, we get a response back, and none of this HTTP stuff is interesting to the service. It just ignores that. What it looks for is this XML payload here, which says that the order has been placed, which is fine. It's fine. It doesn't embrace the web. It ignores all of the useful stuff in HTTP, but it works. It's useful. It's a pattern that we might choose to use. And in a .NET example again, it's pretty easy. We grab a listener context, we look for the post verb, and then we extract an XML document out of the stream. We dispatch to do some processing, and we get an XML element back from that, which we plonk back into our response stream, and then bonk, kick the response back out on the wire. Again, in the time it's taken me to speak that, you probably could have already written this code. It's very simple stuff to build. If you wanted, oops, and indeed, if you've even got my little cheat sheet here, it's even easier. Of course, this stuff isn't the sole domain of .NET. You could even do it in Java. So if you were to build a servlet, all you'd do here is you'd override dopost from the base servlet. You'd extract XML from your payload, from your request reader. You create an order in this case, which is my business logic. And then all you do is post some XML payload back into your payload and dump it back as your HTTP servlet response. Trivial. Again, in the time it's taken me to read through it, you could have already written it, unit tested it, and deployed it. On the client side, same kind of stuff. Pretty easy stuff here. So this is, again, .NET. Let me zoom a little bit. Do like that Mac zoom. So, of course, here we're just creating an XML request using the standard .NET Web Client library, dumping our XML documents into the outgoing request, adding a content type because we're good citizens. We're telling the receiving service that it's going to get application XML. And then we wait for the response. And when the response comes back, we create an XML document from it, and then we're done. We dispatch back a local order confirmation to the calling logic. Easy peasy. If you're a Java guy, this is going to be quite depressing because the difference between the .NET and the Java client, particularly if you're doing Apache Commons, is the Apache Commons stuff is about twice as long. It does pretty much the same thing, it's just a bit more verbose about it. So if you're a Java person, you're doing exactly the same thing. In the interest of time, I'll suggest that you guys probably have access to this material anyway, so I won't read through it. But you are doing exactly the same things here. You are creating a document, creating an Apache Commons client, using the Commons client to post something over to the remote service, and then doing the receipt on the way back, doing the inverse. If you want this code and you actually want to run it, it really is just toy code, but it is available on the restbucks.com site, or soon will be. So, strengths of POX. Simplicity again. You guys could write this now. You already have all the tools installed on your laptop. You could write it now. You reuse a bunch of existing libraries. There's nothing new for you to write apart from the business logic. That's kind of a good thing in a way, because we don't want to really spend all of our time messing with plumbing. We'd rather get on with building business logic. It's very interoperable because, again, it's just XML and HTTP, and everything understands those things. And one strength it has over and above even URI tunneling is that we can now deal with quite complex data structures because we're using XML to encode them, rather than trying to shoehorn them into the URI. So it has some benefits. Also has, as you'd expect, some drawbacks. It's quite a tightly coupled system. The client and server typically must collude on the format of the XML document. Otherwise, the client sends something to the server which the server doesn't understand. So it's quite a tightly coupled approach. And there's not really any metadata involved. I mean, the server may choose to publish XML schemas or something to help the client, but there's really no rich metadata involved here. It doesn't use the web either for any robustness. It kind of ignores all of the useful status codes and so on that the web gives us, and instead expects that we as the developer will deal with any fallout. For example, it will tunnel faults back in XML if we programmed it that way, and it would be our responsibility to handle them. And the irony of this is, and I'm not at all saying that SOAP and web services are the way forward here, but even SOAP and web services had protocols that we could leverage relatively easily for dealing with failure cases. This places all of the burden onto us, which is not a fun place to be. So both of these techniques are web abuse. You can do them. The web is sufficiently pliant to allow you, but they don't take advantage of the web. They miss out on a lot, and because of that, they drop a whole lot more work on us. They ignore status codes. They don't really, particularly in the POX case, support caching. There's no metadata. There's no help if something goes wrong, and so on. They're useful in some situations. But in the general scheme of things, if you find yourself doing one of these kinds of integration, you really want to take a stand back and think diligently about whether it's the right thing to do. Yes, it's fast. Yes, you're going to get it done quickly. But maybe the cost of ownership over the long haul may be significantly higher than you'd expect. So, how do we get better? How do we do better things than treating HTTP as a transport protocol or treating URIs as a remote procedure call mechanism? Well, we need to know a bit more about HTTP. So let's go for another interlude. I like the word interlude because it kind of suggests that it's going to be like a nice, comfortable break where you get a cup of tea, and then no, it's like evil stuff. You have HTTP verbs instead of chai. Sorry about that. But there will be chai later, I'm sure. So, there are a number of key verbs. In fact, there are more HTTP verbs than I've got here. There are a number of key verbs that I think we need to know if we're going to be competent web engineers. Get, we know from the human web. Post, we know from the human web. They're the only verbs that HTML supports at the moment. We also have put. And put has the semantics that it modifies an existing resource or creates a new resource in a client-mandated, as a client-mandated URI. We have delete, and delete asks the server to logically remove a resource from service. It may even actually do a delete on the file system, who knows. And we have head. And head's interesting, it's very similar to get, but instead of returning the whole representation of a resource, for example, returning a whole web page or XML document, it just returns the HTTP metadata. And then, of course, we have the very, very unknown options verb. And options is cool, although it's quite unknown. Options allows me to ask a resource, which verbs do you understand? And the resource may respond with things like, I understand get and put, which means I can read it and update it. So let's look at, oh yes, and I should point out that practical arrow. As you go down this list of verbs, there is a decreasing likelihood of being supported in your favorite web server or web toolkit. As time goes by, these verbs are becoming pretty commonplace. But don't be surprised, particularly if your favorite web server doesn't support options. That's a pretty niche case. So, what's head? Head's useful because it does something like get, but doesn't retrieve a representation. What does this mean? It means I can ask a resource for its metadata. I can see something like its e-tag, or its last modified. I can compare its e-tag to the e-tag that I have of a cached resource and determine they're the same. What does that mean? It means I then don't have to do a get. And if that resource is big, maybe it's a movie file. I don't have to do get again because I'm already up to date locally with what's on the server. So it's a really great bandwidth optimizer. Options allows me to determine which HTTP verbs a particular resource can support. So I ask a particular verb options. In this case, it's a RESTBux order. And it says I can do get, head, and post. That means I can read it, I can ask for its metadata, and I can create new subordinate resources from it. That's really cool. That's the web giving us useful hints. It's the web being self-descriptive. It's telling us, do these things, I'll accept them. Don't do anything else, I probably won't accept those. So again, it's useful metadata, which the web gives us for free. We also need to know a few status codes, and there'll be a test on this. No one will be allowed to leave the room unless you remember 90% of them. The security guards, you've seen those guys? They're pretty mean, and they're trained. They're HTTP ninjas, in fact. And if you're not able to tell them what 417 means when you leave, you get like ninjaed in like a bad way. I don't know what ninjaed means. I guess those swords and throwing stars, maybe. So anyway, we have broadly 5 sets of metadata, status code metadata in the web. 100, that's metadata. The 200 responses, everything's cool. The 300 responses, everything's probably cool, but just go over there because it'll be cooler. The 400 responses, you're stupid, is what the web server is telling you. And the 500 responses, which is, I did something bad as the server. Of course, the HTTP specification suggests a more formal definition of these. So we have 100 continue. If you get 100 continue, it means the operation you're trying to perform will be accepted by the service, so go ahead and do it. It's a kind of look before you leap pattern. Often you can ask a service, if I was to do a post to this URI, what would you say? It's kind of like, you know the negotiations you have with your girlfriend, wife, boyfriend, husband. If we were to go to the cinema on Friday, which film would you like to see? It's kind of that sort of thing expressed in the web. If I was to go to the pub tonight, what would happen? 404 not found would be the response, I'm sure. But I'd like a 100 continue. The 200 status codes, we're used to these, particularly, yeah. I really appreciate it, but it's going to take me a few minutes to process this. So why don't you come back later and check this URI for your result? So the web automatically enables you with some kind of asynchronous kind of processing. So if you get a 202 back with a location header, it's an invitation to get on with your life, and in a while later, look at the place the location header specified, because your results might be waiting. So you might do some polling. And polling, counterintuitively, is what makes the web scale. Weird, huh? Yeah, very weird. So there's some other 200 codes that you might want to look at. I have to say, apart from 204, no content, I don't tend to use 203 much or 206 because I haven't had a use case for partial content in my day job. So the 300 codes, they're kind of like everything's pretty cool. 300 gives us multiple choices. There are lots of URIs that you might choose to look at, with the location header giving the preferred one. 301, move permanently. We see that all the time on the human web. If you transition your blog engine from your old space to your new space, if you're a good guy, you put 301s in there so that people who go to your old blog get redirected to your new blog. 303C other, use for temporary redirects. Use for location-based redirects. It's saying, yeah, you might want to look at this URI as well. We also have 304 not modified, useful metadata saying, yep, what you've got and what the server have got are the same. So carry on with your local representation. And we have 307 temporary redirect. I actually used 307 recently. I'm like ticking off the verbs I use now, the status codes I use. And I used it in a situation where my server had reached its processing capacity. So I'm doing some quite sophisticated speech processing. And 307 says to the rest of my enterprise, I'm really busy. Go to an alternative place to get your speech translated, in which case, in that case, it may actually overflow to some backup system, maybe even a manual system. So that's kind of cool. I like that. It's a really neat protocol. 400 is, you did something wrong. This is quite an accusative tone that the server takes with you. 400 bad request, you sent me something that I just could not make sense of. So don't try and submit that thing again, because I still won't make sense of it. No matter how much you shout at me, I'm not going to understand. Fix your side, then talk to me again. 401, unauthorized. I want to help you, but you're not authorized to interact with this resource. So give me some credentials and we'll talk again. 403, forbidden. Bah. 404, not found. If you're honest about 404 not found, it's basically, yeah, the URI that you're using, Mr. Client, I can't resolve that to a resource. However, beware about being too honest on the big web, because people might choose to probe your URI space, and if you're very honest with them, they might try and find weaknesses. So sometimes you might actually want to use 404 for more than not found. You may choose to use it as a blanket, I'm not going to help you, particularly if you think someone's trying to access secure URIs, resources which should be secured. You may choose to lie, and I'm not saying that lying is positive, but in this case, you may choose to misinform any miscreants that might want to abuse you. 405, method not allowed, self-explanatory. You tried to do a post, I don't support post. If you ask options, I may tell you which methods are allowed. I use that a lot, as you'll see in the later examples. 406, not acceptable, that's to do with resource representations, I'm going to skip that one. Conflict, another interesting one. Particularly when you try to update the state of a resource with an update which the server can't process because the resource is already in some other state. In that case, because of a race condition or something, the server tells you conflict. Useful metadata. It's saying, I've got a different version of the state of the resource than you have. You need to figure out how to bring yourself up to date, and then we can re-engage. 412, precondition failed, really very useful if we're using guard clauses. So if we are using e-tags to actively prevent unnecessary work from being done, if our guards fail, the web tells us, yeah, you specified a guard, the guard failed, so do your recovery action. So 412 is pretty damn useful too. Yeah.
What's the difference between 301 and 410?
Between 301 and 410. So, interesting. So generally speaking, the 400 the 400 codes are the server telling the client they've done something bad. So in the 410 case, it's saying, look, bozo, this resource is not here. And the more you ask for it, the more I'm going to think you're a bozo. So it's kind of an angry response. Whereas the 300 responses are like, yeah, you asked for this, but it's just moved over here. So just come this way and there you go. Use this resource now. So 410 is just a really kind of like, I told you it's deleted. It's like addressing your children, right? I've told you, now don't do it again.
So, bunch of 400 stuff, and we're going to skip past those. The 500 ones, pretty simple. The ones you're really interested in are 500, which is like a catch-all. If you've got some unhandled runtime exception, just 500, okay? That's the easiest thing you can do. And the other one, 503. Again, I've used 503, both 500 and 503 recently. 503 when we take our service down from maintenance. So actually, to the rest of my enterprise, the service still appears to be somewhat functional. Is that a yawn or a question? A yawn, okay. So my service appears to be somewhat functional, but it's helping out other systems by saying, for the moment, don't use me. So that's kind of useful too. So now you know all of the HTTP status codes that are useful. The web ninjas will test you on the way out, so get your cheat sheets ready. But of course, as well as the status codes, we have a bunch of really useful headers in HTTP. I guess that's one of the joyous things about using HTTP as a protocol. It's extensible. And so headers provide contextual metadata to help processing. And HTTP spec provides stacks of these. You've already seen some of them. We've seen the authorization header. Yeah, we're quite used to that when we're interacting with resources that need authorization. We've seen content length. That's the size of the payload in bytes. That's pretty useful. Helps the recipient to check if enough bytes have come through the wire and so on. And importantly, we've seen content type. A lot of the time, the content type is text plain or text HTML. In the computer-to-computer web, much of the time, content type are more machine processable formats like application/XML or application/JSON or application/Atom plus XML. We also have the headers that allow us to do ETAG processing. So the ETAG and if non-match headers. So these are these two, if modified since and if non-match and so on, help us to put guards in place to prevent unnecessary work. So for example, I could say, if you don't match this ETAG, please do the HTTP operation I've just asked. But if you do, don't bother, because then it's clearly superfluous work. So we're already being good citizens and saying, don't do this if you don't have to. We use the location header a lot too. The location header is really self-explanatory. It determines the location of a URI. Of a resource. It gives you the URI of a resource. We often use this in response to creating a resource. So sometimes we'll post something to a service which will result in the creation of a new resource. The service, being a good guy, will give us a 201, that's created, that's helpful, and a location header back to say, I created something and here's where I created it. User agent, worst thing on the web. Crime against humanity. Why a service needs to know your user agents? Because web browsers are built by monkeys. And they all implement their specifications inaccurately. So nowadays, on the human web, we have to send a user agent string so that the receiving web server can figure out how to render HTML for us. That sucks. On the computer-to-computer web, if you use user agents, the web ninjas will attack you in your office buildings. They can get in through security with ninja skills, and they will totally attack you with ninja swords. It's a bad thing. Final header that you must know, I think, would be www authenticate and date. Dates are really so useful, right? Every web request and response should have one. Other headers that you might want to know that are quite useful, accept, where the client tells the server what format he would like any responses in. So he may say that I will accept only application Atom plus XML or application Atom plus XML and, well, if you can't generate that, could I have JSON? And if you can't generate that, could I just have XML then? So that's quite nice. It's a kind of content negotiation thing. Oh, just one there. One there, cache control, metadata for caches. Allows us to control the liveliness or liveness of data in caches. So we get some quite fine-grained control over our federation of cached representations in the network. Going to skip those. Going to skip that, going to skip that. So, importantly, HTTP RFC, this is RFC 2616, is authoritative. If you are going to build web-based services, this is practically all you need to know. And okay, it's this thick, and it's not very interesting, but at least everything you need to know is in one place. If you contrast that to Learning Corba, well, I needed the Corba spec, and then I needed the Wieniawski and Henning book, which is like this thick, or maybe this thick. It's a really big book. And then I needed to look all over the web. It was all kind of like bitty. Same deal for the web services protocols. You need to pick up thousands of protocols from Oasis and IBM and Microsoft, and then you need to read your particular toolkit stuff, and it was all kind of a bit confusing. The web, at least, has one document which is completely authoritative. And we'll also reference some other RFCs in there, the URI RFC and so on. But it really is a pocket-sized guide to doing integration. In fact, one of the things on my desktop, one of the very few things on my desktop is a copy of the HTTP RFC. Quite why I called it an RCF there is beyond me, but no one has yet corrected me. So it's a good thing to have with you when you're building web-based distributed systems. So let's build one, or at least pretend to build one. So let's use the web. We know now you've been imbued with the knowledge of status codes and metadata and all sorts of fun stuff. So let's get beyond our fixation on tunneling, POCs, and SOAP. Let's start to embrace the web as a distributed application framework. Because the web is more than a transport. HTTP is an application protocol. It's not a transport protocol. It's much more like SMTP than TCP. So it's a transport protocol, yes, HTTP. But we have metadata in those headers. We have a fault model, status codes. We have a component model, the uniform interface, and a runtime environment which caches, servers, all that kind of stuff. So it actually is a framework. And the first thing we can apply that framework to is CRUD, create, read, update, and delete. So controlling, if you like, things that probably resemble database records over a network. And CRUD is a level 2 service. It's relatively sophisticated. Amazon S3 is a CRUD service because you create objects in an Amazon S3 bucket, and then you sometimes read them, sometimes you update them, and when you're bored with them, you delete them. Very successful Amazon have been with that. So it is a level 2 service. It uses lots of URIs because the objects that we're going to be CRUDing are all identified by their own URIs, and it embraces HTTP. It's going to use several HTTP verbs, and we're going to take advantage of numerous HTTP status codes to help coordinate us through our CRUD services. So let's look at POST. Creating a resource on a remote server, we do with POST. The protocol is very simple. We post to a particular well-known URI, in this case /orders, because this is the, RESTBUX deals with. What differentiates RESTBUX dialect is that it's all in British English. So all of our XML tags have U's in them and S's, and it really confuses the Americans. It's wonderful. Although the book is going to be written in American English. We might have to change that. Anyway, so you post something over, and if RESTBUX is being well behaved, and if your request was well formatted, we send back 201 created with a location header. This is rich metadata. Firstly, you get a 200-ish response, which says, okay, brilliant, I did that. That's great. You automatically know now that RESTBUX did what you asked of it. Better still, we narrow it down, and it's a 201. And that says, I created something for you. Wow, this is brilliant. None of the remote object protocols I used to use told me that. I just used to get nasty exceptions that I couldn't understand when things went wrong. This is great. It says, I created it for you, and better still, if you ever want to look at that order, here's the URI for it in the location header. So that's cool. So it did what I wanted, it told me it did what I wanted, and then it told me where it was. This is a lovely service. So what can I do now? I can do all sorts of other things with it because I know the location of that order. If I sent a bad request, however, so maybe I used American English in my XML body, which is terribly, terribly uncool in the UK, I'd get a 400 bad request. The service would say, the thing that you sent me, I don't understand. Please stop using Zs. Please put U's in, or something like that. As a client, I now know that I'm not invited to talk to the server again until I've rectified the problems, until I've created a payload that the server will understand. And of course, if RESTBUX is misbehaving, it sometimes does, then it will throw some kind of internal exception, which we'll report back to the client as a 500. And we'll say to the client, yeah, sorry, we're just really in trouble right now. Go to Starbucks. We can't help you. Which is kind of cool. So post creates a new resource, but the server decides on the location of the newly created resource. We see it in the human web all the time. You post a comment to a weblog, the server decides on the URI for that comment. Easy peasy. In the programmatic world, we use it to create coffee orders. We might use it to create a new HR record when you join a new company. We may use it to even append HR history onto your record. So all of the misdemeanors that you guys have committed during your day jobs, the HR people can record by posting. On the wire, pretty simple stuff. Bog standard HTTP post with the host, telling it the content type. In this case, it's a particular XML dialect. Being a good citizen, I tell the server how long the content is, and then bang. All this is just XML. But of course, RESTbucks, as they make my coffee, may change the order. They may change its status from being made to prepared. They may add things like other links into my order to encourage me to buy more coffee. But if all goes well, I just get a representation of the order back. If I use the wrong URI, then I get 404 not found. I don't have that order. Or if something goes terribly wrong, then we'll issue an internal server error. So semantics for get are retrieve the representation of a resource and be idempotent. That is, any side effects that it causes, the client cannot be held responsible for. Ideally, no side effects, period. But of course, we know that that's an academic goal, because even an HTTP GET request often results in side effects in terms of logs being written. But the point is, those side effects, you can't hold the client responsible for those side effects. On the wire, it looks like this. So I'm saying I want a particular resource representation. It's the order that RESTbucks created for me. I'm actually stating here that I'd like it in RESTbucks XML, please. Maybe RESTbucks could also give it me back in text, or maybe it could give me back in HTML if I wanted to integrate directly to the browser. And of course, then the host ID is just to restbucks.com, and everyone notices that I missed the date out. Slap on the wrists. That's what happens when you write code in PowerPoint. Okay, one point I should perhaps bring up there. There's a debate raging on the web whether using the accept header to allow me to declaratively specify the kind of format I'd like the server to respond in is a good idea versus you are encoding that in the URI. So you could imagine that I could actually do get/orders/1234.xml and use that convention to ask for a .xml representation, or .html, and the server interprets that as a request to ask for an HTML representation. The accept header exists and it's used. At the moment, I have flip-flopped, but at the moment I'm tending to use the accept header to specify client preferences for response formats from the server. So on the wire, the response is pretty straightforward. I get HTTP 200, okay. I successfully did what you asked me, and here is the response. And you notice, if you've got binoculars and you can look down in this corner, RESTbucks have indeed changed my order. They now have a status code in there which says pending, which means the barista is probably about to make my coffee. When GET goes wrong, easy. Because of the shared understanding of GET, that it's safe and idempotent, just get again. If you get a 404, maybe the server's just misbehaving for a while, get again. Get again and get again. You can get to your heart's content until you decide that you're bored with it, in which case then you can give up and do some other forward or backward error recovery. So, if you want to, you could build this in a, sorry.
When you're using an XML type of payload, isn't that also causing some coupling? Because the client needs to understand the schema.
Okay.
Would there be a way to notify the client of any change in schemas?
Okay, so the bit of the question that you might not have heard because the microphone wasn't there was, if you're using an XML dialect, how do you tell the client about the kind of schema that they might want to use? Actually, so XML is a real Vietnam of web, to be honest. It's like a situation you get stuck into and you're like, we really didn't want to do this. The web runs on media types, on content types. And so that's the important thing. If you look up the restbucks.com media type, Yes, it's an XML dialect, but actually it's not just XML. It has some very specific application semantics. So the media type is what's important. And so if I see the media type application / Atom plus XML, I know I have to go and read the media type specification for Atom. And that tells me a number of things. It tells me that it's Atom formatted, and I should expect to find hypermedia links in there. And that's the important thing. That's the important thing rather than the schema per se. Now, even one of my co-authors disagrees vehemently with me over this. And he says, well, you should look from XML up. And say, so you should look for the schema and dispatch based on the schema. And the schema is the shared thing that we communicate via. I disagree with that. I think I'd prefer fewer, more general media types. I think that gives us better interoperability versus going down the quagmire of XML schema-based integration. We tried that with web services, and it was very brittle. So I think fewer, more general media types are preferable to more specific XML schema-based dispatching. In fact, if you went to Craig McClanahan's talk the other day, he actually went to the extent of saying every URI should have its own media type. Now, I think I wouldn't agree with that either. I think that's probably too many media types. But fewer media types is generally better. And the XML payload, well, that's a second-level dispatch issue.
The number of media types really depend on the skill of your application, isn't it?
So I'd agree with that to some extent, although I would even still have in my mind a design goal to minimize the amount of media types I share with you guys, because it's just more work you have to do to try and understand what I'm doing. So in RESTBooks, we have one media type, which is RESTBooks plus XML. And that tells you, if you read the specification, if you could read the specification because it's not available anywhere, but if you could read our RESTBook specification, it would say it's XML, but you can expect to find Atom links in there. Process it accordingly. So it doesn't actually say, and look at the schema. In fact, so I'm on a bit of a sidetrack here, but it's a good sidetrack. Schemas are a pain in the butt. Schemas encourage tight coupling. I'd much rather you sent me a bunch of XML and I just XPathed out of it the bits that were interesting to me. That means even if you change the format of your XML, I've still got a chance of understanding the document you sent to me. Whereas if I'm a stickler, if I'm an Indian immigrations officer and I'm a stickler for the exact form, and you must match exactly this schema, otherwise back on the plane kind of guy. Phew, they let me in. It was worrying though. One minor deviation from that form breaks our communication. Whereas if I use the XML schema as a kind of guideline for the kind of information I can expect, I can build a mechanism which is much more decoupled from the schema, and then I'm much more tolerant of changes in that schema. So media types are best, schemas are an implementation detail, and not a very nice one at that. Does that kind of cover your question? Wonderful. Okay, so you could even build this JAX-RS was the amount of configuration I had to do. But having seen Mike Keith's lecture yesterday, I'm fairly emboldened that the Java guys are finally kind of condensing some of that 10,000 XML files you need for every Java application. 20,000, whatever it is. It's a large number. It's certainly more than I can cope with. So put allows us to update. And the protocol that we use for put is pretty interesting because it introduces a status code that we're not very familiar with. If everything goes well, what put allows you to do is like replace the state of a server-side order, or resource, in my case they're orders, with a new order. So I do a put and I give the new order, in this case encoded as XML, over to the server. If the server's happy with that, it responds with 200 OK. Brilliant. You've now replaced your old order with a new order. That's OK. Maybe I'm at a point in my workflow where that's still permissible. Haven't paid for it or anything. If I'm not allowed to do that, I'll get a 404 not found back, saying, yeah, that's a URI you're not allowed to interact with. Naughty client. More interestingly is 409 conflict. What this is telling us is, yeah, you tried to update the order, but the order isn't in a state where I'm prepared to accept your updates. So perhaps I tried to change my coffee from being a latte to a cappuccino. But unfortunately for me, the barista has already made me a cafe latte and is now waiting for payment. At that point, I can't change my order. If RESTbooks allowed that, we'd go out of business very quickly. That would be a bad business protocol. So the web, again, is giving me rich metadata saying, no, you can't do that. There's a conflict in the state that you're trying to update with the state that the server already has. And then, of course, our famous get-out-of-jail-free card, the 500 response when something's gone badly wrong. So put creates a new resource or overwrites an existing resource at a URI mandated by the client. And that's what distinguishes it really from post, because when you post, the URI of the created resource is mandated by the server. Put's very client-friendly. Put is also idempotent. If I put a resource, put the state of a resource, and I put it again, and put it again, and put it again, the semantics are as if I only put it once, because it makes absolute, not relative changes. So that's kind of useful. It means in the presence of failures, I'm quite at liberty to just put and put and put and put until my put gets through and I get a response back from the server. Particularly useful, for example, if I'm trying to make a payment and the network goes down for a couple of milliseconds and I then say, oops, okay, put again. Because I'm using put, I shouldn't be charged twice for that payment. But it's not safe like get. Put does change state. It just changes state in an absolute way. So on the wire, I might choose to put this new request. And the updated content is that I've changed the kind of milk I want. Maybe I changed it from skim milk because I was on a diet, and now I'm thinking, well, you know, I've only eaten 17 naan breads for lunch. Maybe I can have whole milk rather, in my coffee. So I do a put, and hopefully, if everything goes well, I get an HTTP 200 response back and content length naught. It's basically the server saying, yeah, I did it. And the thing that you sent me is now the state that I'm holding for that resource. If the server didn't want to be minimalist, if it wanted to be verbose, it's perfectly at liberty to send me the representation of the resource back just to reconfirm that we agree. When put goes wrong, put again. So if you get 400 or 500 errors, apart from 400, 400, obviously you can't, but just put again, try again. Because put is idempotent, you are at liberty to do that. But if we get some of the more funky errors, 409, 417, then we have to think about doing some forward or backward compensating work before we retry. What these errors tell us is that the state on the client side is out of sync with the state on the server side. So perhaps now we have to use a bunch of gets to resynchronize ourselves with the state on the server side before we're allowed to do more work. And again, these aren't bad things, right? I mean, yes, they're kind of inconvenient because you'd prefer 200, but this is the web giving you rich metadata and enabling you to make smart choices about how to continue along the workflow. And you can build it, you'll be not very surprised to hear. So you could build it even in WCF. So, you know, if you got bored of building it with just plain old HTTP, you could go and get yourself a copy of Windows, install .NET 3.5.1 and build it this way. Importantly, I guess, you'll see that through the course of this tutorial, there's several different implementation choices I made. And that wasn't just to confuse people. It's just to demonstrate that this stuff is so widely known about that your implementation choices are many. You pick the one that perhaps you're most comfortable with. You pick the one that's most strategic for your organization. You pick the one that you quite fancy learning. And you work with it. In WCF, same old WCF stuff. Create a service contract, and in this case, we use the relatively new web invoke method. We specify that it's going to respond to puts at the URI template /orders /curly brackets order ID, and here's the method that WCF will dispatch it to. Of course, we then need to go away in WCF and write a whole bunch of code to help the framework deal with serialization on our behalf. But then, of course, it just works. And if I was a Microsoft guy, I'd flip up Visual Studio right now and try and convince you that, you know, with just 2 clicks of Control F5, you've got a whole web service. I won't try and convince you of that. But you can do it in WCF. So our final verb in CRUD, delete. Send a delete of a particular order. Maybe you decided that Restbucks really isn't for me, and I'd like some decent coffee from Starbucks. So you go to the competition next door. You decide to cancel your order, and the way you do that is by deleting. You know the URI of the order because it's the URI that you got in the location header when you first created the order. So what do? You do a delete on orders /1234, and hopefully you get 200 OK back. What does that mean? It means you and Restbucks have reached the end of your workflow. You've cancelled your order. We're sorry to lose your custom, but now get out of my shop. No, it doesn't. There isn't a protocol for kicking people out of shops. There should be. It'd be cool. Of course, you may have picked the wrong URI. You may have typed 1235, in which case you'll get 404 not found. You might get a 405 method not allowed. Now that is interesting. Again, like when we saw the 409 case, when we're doing an update, 405 method not allowed is telling us useful information. In Restbucks, we use that when we've already made your coffee and everything becomes immutable. Your order becomes a matter of audit record. in which case you're not allowed to delete it because that would really screw our accountants up. So your coffee's waiting, you've got to pay, we've made it for you, you've entered into a contract with us. 405 method not allowed says you can't delete your order. It's a matter of record. And our catch-all, service unavailable. So semantically, delete means stop the resource from being logically accessible. If everything goes well, we get 200 OK back. Delete, it's really interesting. It's also idempotent. If something fails to delete, you can just try and delete it again. Because if you delete something once or if you delete it 10 times, it's still deleted. So if something does go wrong when you're deleting, try it again. If delete really goes wrong, so some 400 responses like 412, then you have to try and do some forward or backward compensation. In this case, you try to delete something which has become a part of our system of record. So this is your order. You can't delete that now. Your only option is to pay us and drink your coffee, or we call the police. So CRUD is good. It really is. It's not hypermedia, it's not RESTful, but it's good. It gets us involved in HTTP. It gets us thinking in terms of HTTP as being a coordination platform for distributed systems. It gets us thinking in terms of metadata, status codes, all that good stuff, in terms of verbs, in terms of treating HTTP as a big, big worldwide container for applications. And CRUD is good, but the web doesn't stop at CRUD. And one thing I'd love to convey to you is often when people say, I'm building a RESTful service, well, 50% of the time they're just doing web abuse. They may not know it, but they're just abusing the web. The remaining 50% of the time, 40% of that, they're doing CRUD. They're not doing REST because they're not embracing hypermedia. Now, there is a tech interlude here, which I would, time permitting, go through. One way of describing CRUD services is with a metadata format called WADL. WADL is evil. WADL is the web application description language. It is the equivalent to the web as WSDL is to web services. The slides will be available for you so you can do the WADL stuff in your own time, but I'm way, way behind, so I'm going to whiz through this at breakneck speed. So basically, WADL just describes the resource structure of your service, the kind of formats it expects, and the responses in terms of status codes and so on that you can expect when you interact with a particular resource. Another tech interlude, and a real quick one, semantics. I'm not a massive fan of the big semantic web, the web is a database vision. It will play out at some point, but right now, being a pragmatist, I like to innovate at the edges of the network. And I think we can use microformats to start helping us. And you'll see where this is leading. I would like to raise the level of interoperability between our services by talking about human, business-level vocabularies. I'd like to be able to mark up documents in a way that business people understand, as we already do in good application development. I'd like to start embedding semantics into my payloads. Semantics that machines can use to help them process. And I think microformats are the way to do that. We've already seen that microformats are super useful on the human web. For example, if you visited my web page and you went to my contacts, and if you had the right plugin, you'd automatically be able to generate a vCard from that because I've got the right vCard markup embedded in my web page. We can take those same techniques and we can apply them to computer communication. For example, Atom does this already. When you see an Atom feed, you'll often see the Atom pub links in there. So a protocol which is designed for dealing with publications, managing publication. And you'll see things like rel equals service.post. That means when you see this link, it's the service post link. It's the way that you would post a new entry to the Atom feed. If, for example, we were in a banking domain, a consumer banking domain, we may see rel equals withdraw.cache, and maybe that's part of some RESTful ATM protocol. And you know that if you follow the link, because you've seen withdraw.cache and you understand that semantic markup, the resource that you will go to will enable you to withdraw cache. So we're starting to raise the level of abstraction to something a bit more friendly. And I want to use that in hypermedia formats. Media types, as the gentleman in the audience led us to earlier, they rule on the web. They're important. They're what sets out our contract. The web's contracts are expressed in these. If I tell you something is media type application XML, you know I'm giving you an XML document. If I tell you something is application Atom plus XML, you know you're getting an Atom document formatted as XML, and you should process it as such. And some of these types are special. Atom and XHTML are good examples. They're special because they're formats which describe the web. They have links in them. Plain old XML, no links. Atom's XML, links. And links are good because they lead you to other parts of the web. They, in fact, enable us to describe protocols. Links allow us to describe protocols and implement workflows. So I'm going to skip this. So plain old XML isn't a very good format because there are no links in it. It's a dead end from a hypermedia point of view. We could turn to Waddle, we could turn to URI templates, but they're yucky solutions. Instead, I'm going to skip the URI template stuff. Application XML isn't the type you're looking for. Instead, why not use something like XHTML, which has links in it, or Atom, which has links in it. These links mean that if I consume one of your resources, I know that I will be given links to other resources that you want me to interact with. It's the same thing if you've ever shopped at Amazon or similar. Amazon give me links as a human, and those links corral me through Amazon's workflow, from selecting the book I want to buy, to putting my credit card in, to getting my postal details sorted out, right the way through to give Amazon my money. No reason why we can't do that for computers as well. Amazon is happy to describe a protocol to humans in terms of links on web pages. Computers should be happy to describe protocols to each other in terms of links between hypermedia documents like Atom, or, in my case, a particular XML format which has hyperlinks in it. So for RESTBux, we made the choice to create our own hypermedia format, which has that really unglamorous media type. It's an XML hybrid, but if you read the spec for that media type, it would say it's XML, but you'll find Atom links in there. Process the Atom links because they will lead you to other resources you have to interact with. And this is important because only hypermedia formats allow us to build RESTful services. So here's an acid check for whether you're building a RESTful service or not. If you've got XML as your payload, plain XML, you're not RESTful. You can't be because you can't describe links. And links and hypermedia are what makes a service RESTful. So, and I'm going to probably end on this section because, by golly, I talk a lot and don't get through much. Links are good. Links allow us to describe protocols because they tell us, if I consume one of your representations with links in it, you're telling me, now go here and interact with this resource, or go here and interact with this resource. You're starting to describe a protocol for me. That protocol itself may map onto your workflow. So you're starting to describe business level semantics at me through links, which is really important. So describe contracts with links. Atom Pub already does this. It's a whole protocol expressed in terms of links between resources. And what links are, they are advertising potential state transitions that we might want to take through a workflow, through a protocol, to get us from, in this case, selecting some goods, confirming what we wanted, paying and shipping. It's a classic Amazon workflow. And so links become APIs. If you think about, for example, this cut down XML representation here, it contains a link with a rel value payment. What's that telling me? If I understand the microformat, then I've got a link to some resource which the microformat vocabulary tells me is something to do with payment. I might want to follow that because I might want to pay. Or I might want to follow the link to postpone, which means add something. It's a resource which will allow me to add a book to my wish list, so maybe I can persuade my wife to buy it for me. But these links inside a particular hypermedia media type give us a contract. So we don't need things like WSDL in the web because we already have links and hypermedia. Taking all of what we've discussed today together, we have a framework. We've got metadata, we've got status codes, we've got a way of describing protocols through links. We have an application framework that's been sitting there serving sports results to us for the last 10, 12 years. And now we're finally at the most mature services, RESTful services that we can build on the web. We're finally at the point where we can talk about services which embrace many URIs, which use the full suite of HTTP verbs and status codes and metadata to help us coordinate interactions, and critically, that use formats that allow us to describe protocols. And all of that, we can then do the most boring, enterprisey thing imaginable, build a bloody workflow. So if you think about how a workflow would work in a traditional enterprise with message-oriented middleware, we'd think about interacting with it by sending messages in and receiving messages back. Gregor Hope and Bobby Wolf, Gregor Hope wrote this up for his blog. Gregor and Bobby Wolf, of course, famous for writing this up in their Patterns for Enterprise application integration book. But in a traditional integration scenario, all we know is the conversation state. We know a protocol expressed in terms of messages that we must send in and expect to receive back. But I think we can do the same thing in the web. I think we can create web-friendly workflow because we can model that contract. Instead of by using some static description like WSDL or WSBPAL, we can model it just by using linked hypermedia representations. So here's RESTBUX again, and you're quite familiar with this now because I create an order by posting to it. Yeah? And what happens is, behind the scenes, very slowly on this Mac, RESTBUX creates an order. In real life, we're much faster, with really fast cashier. And on the wire, you know what's going to happen. I do a post with an order, and I get back 201 created, and the content type, importantly, is this RESTBUX XML stuff. Remember what that tells me is, expect links. And if you look through here, bang, there's a link. And the link has been micro-formatted, and it says payment. Interesting. What is this? The start of an API? Yes, it is the start of an API. It's a contract which RESTBUX are expecting you to honor. They're expecting you to interact with this payment resource and pay them money for your coffee. Of course, if I make a mistake, fine. I've still got the HTTP verbs at my disposal, so I can say, whoops, I ordered the wrong kind of coffee. I'd like to update it. I want an extra shot. So I can ask options. What can I do to my order? And at this point, RESTBUX says, you can still get and put. I can still read it. I can still update it. So just because we're hypermedia doesn't mean we don't have the existing HTTP stuff to help us. The hypermedia adds more. It's a layer atop HTTP. So I can amend an order by doing a put. That's fine. We know how to do that. We saw it in the CRUD example. And on the wire, come on, it's as you'd expect. And I'm going to flip through these because we've seen these in the CRUD one, and I'm really running out of time. So I can check my order confirmation by getting it. And on the wire, if I confirm my order with RESTBUX, they're still pretty insistent. Look at this, they are really insistent that I should interact with this link here. So, okay, I'm going to interact with that link. I'm going to put a payment to the resource identified in that link. How did I know to put? Of course, I ask options, and it tells me I can put. So I do a put, I pass my payment over the wire, RESTBUX creates a new resource with a new URI which represents my payment. How did I know to put? Simple, ask options. You've told me I have to interact with this resource at the end of this payment link. What can I do to it? RESTBUX tell me I can read it and I can write to it, I can update it. On the wire, looks like this. It's the same put request that we did when we updated the order. Except this time we're using it to create a new resource, and because we're dealing with money, I like the idempotent nature of put. If something fails, I put again. If something fails, I put again. And then RESTBUX is responsible for making sure I get billed only once. So let's check that I've paid. If I now do a get on my order, look at the representation I get back. Where's the link gone? It's gone because that part of the workflow has been completed, and I am no longer being invited by RESTBUX to interact with the payment resource. It's closed off to me, so the contract's changed. So RESTBUX have nudged me through the workflow. They've said, follow this link. I followed it, and I came back. Don't follow any more links. End of workflow. So now I guess I'm waiting for my coffee. That's really cool. It's totally simple, right? And it's a really kind of dumb example using a coffee shop. But you can see, you can infer quite how powerful this is when you're building bigger, more sophisticated systems, because you're literally corralling your clients through a workflow just the same way that Amazon corrals humans through its workflow. Of course, the clients need to be a bit more sophisticated. You may not want to build them quite so imperatively. You may consider using declarative techniques to build these clients. So you may set goals and imbue your clients with facts, which they use to interpret their way to the goal. God forbid, use a rule engine, use Prolog. Yeah.
I have a question. If you need to invoke some methods, how do you do URI internally? Let's say we need to pay and we need to invoke some method to get us authenticated and get some money.
Making my coffee. The barista was executing the business workflow on behalf of me, the client. So eventually, once I've paid, we drink my coffee. Now, I'm at 3:45, so I'm going to try and wrap up. What do we learn from RESTBooks, particularly the hypermedia stuff? Well, we know that HTTP has a really rich array of header and status combinations. HTTP, the web, is a coordination platform. Hypermedia layers a protocol-centric view atop a coordination platform. And these are very enterprisey terms that I'm using now, but the web has those capabilities, those facilities built in. APIs in good RESTful applications are constructed out of links. Links describe state machines, they describe protocols, they describe workflows. The same things that we did traditionally with enterprise middleware. And while XML might be fine for CRUD services, we really want to use hypermedia formats if we're going to build RESTful services rather than CRUD services. Because at the end of the day, it's all about state machines. Now, ladies and gentlemen, with the most sincere of hopes, I would have got further through this. I'm afraid I'm going to have to leave it there for today because I've run out of time. You do have, I believe, access to the slides for this. They will be made available to you by the organisers. And I'm more than happy to, for you guys to drop me email. If you Google for me, you'll find my website. My email address is on there. Do drop me a line if you want to discuss this any further. Otherwise, if you have any feedback that I could definitely use in my book, I'm all ears. And I would just say thank you very much for hosting me, and I hope you found it vaguely useful. Thank you.